This is Linux In-Laws, a podcast on free Libre open source software, broadcasting from the United Kingdom and Germany.
Welcome to Linux In-Laws, Season 2, Episode 41. Martin, how are things? Especially now, given the fact that you're back from traveling.
Well, traveling is underrated.
Is it?
Or overrated.
So what is it, underrated or overrated?
No, it's overrated, especially in the winter when lots of people spread lots of diseases.
Right.
As I have personally found out. Anyway.
Did you catch a bug again?
What do you mean again?
I mean, we won't go to the details, but Martin has been known to suffer from quite a few ailments, let's put it this way.
Oh, I lead a sheltered life.
People, you have just listened to the understatement of the century. Sheltered life. Does your wife know about this, Martin? I'm just guessing. I'm just asking that.
Indeed. Anyway, how are you?
She doesn't.
You survived foster.
This is not about me, man. This is about your love life. This is about your wedded life.
Oh, that's fine. Thank you. Yeah.
Are you sure, Martin? Because I'm not. Okay. No, foster was great. But back to your marriage.
I think we should focus on our guest. That is far more interesting.
Anything goes. And with that, we would like to welcome our guests. Full disclosure, they will introduce themselves in a minute, but we share some common history. And with that, over to you, Guy and Roy.
I'm Guy. Thank you for having us. How do you want me to start? Do you want me to give you some background about our joint background?
Just introduce yourself. Leave out the sketchy common patches of our joint past, and then you're good to go. No, jokes aside. Just say who you are, what you do, and I fill in the rest, including the juicy details. I'm joking.
Okay, we can also get the jokes thing about you. And our past, right? So I'm Guy, CEO and co-founder of FalkorDB. We've been doing that for more than a year and a half. With me, I have Roy. I'll let him introduce himself in a minute. My background in general, working on databases. I'm doing databases for more than 20 years, mostly low latency, real-time databases. I've been the VP R&D of Gigaspaces for about 8 years, back in early 2000. Then done my PhD in transactional memory. And lately, before FalkorDB, I joined about 7 years ago Redis to establish the innovation group, where I kind of led this group of innovation under the CTO, where we develop a full suite of products from time series, search engine, vector database. And one of them is FalkorDB, that was led by Roy, and I'll let Roy introduce himself and what FalkorDB will be doing.
So first of all, thank you for having us on your show. So I'm Roi Lipman. I'm the CTO and co-founder of FalkorDB. I I've been working with Guy, I think, for the past 6 or 6.5 years now. FalkorDB, our current company, and the graph database which we're developing started out as a hobby project about maybe 8.5 years ago in my living room, and it's just been a hell of a ride since then, working through Redis and then creating our own company.
People, you've just listened to the 2 understatements of the century, I suppose. Full disclosure, Martin and myself met at Redis, and this is also where we met, Guy and Roy, all those years ago, when I think Redis turned into a multi-model database with the first commit by Salvatore of the modules, right? That was in 2014. Redis, of course, for the 2 people who have been living under a rock for the last almost, I'm almost going to say century. Redis, of course, started out as a cache in 2009 as a key value store, and the big feature was actually to store all the keys and values in memory. So persistence was optional. That was later introduced, and as I said about So that was a prototype of a NoSQL database, and the idea was basically to introduce on top of this key value store additional bits of semantical sugar, I'm almost tempted to say, in terms of turning Redis, as in this in-memory database, into a multi-model database that was able to do search, documents, time series, graphs, and all these other bits and pieces. And what was then known as RedisGraph subsequently evolved into FalkorDB when Guy and Roi spun out the company when?
A year and a half ago.
Okay.
Yeah, 2023, July 2023.
So maybe we should start then and there in terms of why did you actually took the IPs and build your own company?
So back in July 2023, Redis announced end of life for RedisGraph. I think for a good reason, because Redis kind of spread thin a bit with this multi-model idea. Like we were pushing it all over, right? But at the end of the day, each company is really, really good in practically one thing, and Redis is really good in this key value store. Redis is super good in key value store. Redis is really good in anything around this key value store, document database, vector database, like things that are simple and easy to consume. And I guess the graph database was a different beast. It's something that, at least from the Redis DNA, was conceived as approaching different persona. And Redis was right about it, right? Redis wanted to be focused on its core component. And so Redis announced end of life of RedisGraph, but we knew we have in our hand a superior technology. We knew our graph database is by far the fastest, the strongest, and the most interactive one. And we knew that because first, Roi invested so much time in that and brought such a unique technology and such innovation. But we also managed to get many customers working with RedisGraph. And that's when RedisGraph was considered like a side project in Redis, not like a main project, not as a main technology. But even though we managed to get big brands, top 100 companies working with it in mission-critical applications. So we knew there is a demand, we knew there is a need, we knew that it's a super unique technology. We knew probably Redis wasn't the right home for it because it was a bit disruptive for the main market that Redis was trying to target.
You mentioned something like a different persona as well.
Exactly. Yeah, you're right.
Do you mean you need a different kind of user, or is it different use cases it's aimed at?
I think the sales cycle is very different than the sales cycle of Redis. What's so unique about Redis is that the adoption of Redis compared to almost any technology that is out there is global. Like you're probably not going to find too many companies, or maybe in one end, that are not using Redis in some way. Most of them, by the way, not even aware that they're using Redis. They might using it as a caching, part of their WordPress, part of their, Spring, even those who are using Ruby on Rails, they're using Redis somewhere. Redis is used everywhere. Like 98% of the companies or 99% of the companies, software companies, are using Redis in some way. The sales cycle of Redis is usually super fast, super short, and what Redis, the company, brought to the market versus the open source was mostly the ease of use, ease of deployment, managed version on the cloud. You don't need to pitch to developers to use Redis because they all love Redis. Redis is really the most lovable database for years. When you are working with a graph database, you are approaching a different persona because that's usually you target the architects most of the time. Those who want to redesign the way they are working with the data set, they want to remove the limitation working with relational database. They want to have the flexibility of using a graph database. It's a different sales cycle. And in our case, it was even opening a new door to the market because graph in general was considered before Roi brought the idea of having a super low latency graph database, was considered as an analytics database, was mostly considered as something that is used as for offline processing, for batch processing, for analysts, not used as real-time, low latency user interactive applications. Like if their data is flexible and they want to keep it flexible, they don't have to compromise. They can stay with the graph database. They don't need to compromise or denormalize the data or create some duplications or move into some document database and then maybe convert back. They can just look at their data as it is, meaning as a network, as a graph, as the most natural way to look at the data, because this is how life really is. Life is one big network. And that's kind of open a new market. But as I mentioned before, it's a bit different than the regular Redis sales cycle or the persona that usually Redis is targeting.
Got it. I mean, there are, of course, other alternative graph databases out there. Would you, clearly Neo4j being the original example, would you consider those as, let's say, the having the same problems? Are they? What does like a RedisGraph or Falkor bring to the table apart from the faster responses potentially? There were a few attempts, right? There's Neo4j, there was TigerGraph, there was a let's say a bit of an influx of graph databases at some point in time.
Don't forget Arango and all the rest of them, right?
Yeah. Like there is a long list of graph data, but not long as other maybe verticals, but there's a nice chunk of, I would say, 20, 30 pretty mature graph database out there. You mentioned Tiger, you mentioned Neo4j, there are others. Most of them super good, like amazing tools. They have very nice flexible query language. They can do very nice analysis of your data. But they are not focused on low latency knowledge serving or low latency graph queries. We never targeted the analytics market. We never tried to say we are the big data solution for graph database. We were always about, you can store big enough graph on our cluster or store many, many graphs on our cluster, but in the intention of retrieving the knowledge in a low latency, meaning milliseconds or in some cases in sub-millisecond. So the whole user experience end-to-end will maintain a smooth and super interactive experience. So you won't have to think, if I'm using a graph and I need it in user interactive, then I'll have to put something in between, maybe another Redis, or put some denormalize the data in some document database. No, you can just work with your graph database with your user interactive application. When you need to retrieve data, when you do, on-the-fly fraud detection, it's okay. Run your query on the graph, on the fly, whenever a user is doing something, whenever you need to do fraud detection verification. You want to use it for access management? That's great. Use it on the fly, retrieve the data. Whenever someone is trying to touch something in one of the resources, you can just query the graph on the fly without questioning, will it impact the end user experience? Because we are promising you'll get a low latency experience.
Got it. And so obviously it was born out of RedisGraph, right? Is that what you're taking forwards with FalkorDB, or are you, let's say, I wouldn't use the word reverse engineering, but building that kind of the Redis part into RedisGraph, or building it from the ground up? Obviously RedisGraph was a module, right? So is that the same approach that FalkorDB is, or are you rebuilding a lot of that kind of core Redis functionality?
At the end of the day, I reckon FalkorDB, and correct me if I'm wrong, Guy Roy, is still a module sitting on top of Redis core.
Yeah. The architecture is still the same. The architecture, it's a continuation, a complete continuation of RedisGraph. We continue from the same source code. We forked it and continue from there. It's still using Redis as a container. Redis is, as you mentioned, Redis module architecture is super flexible, and really mature and very stable, by the way. So it gives us we're using Redis, using this module infrastructure as a kind of container, which gives FalkorDB the ability to do clustering, replication, persistency, failover, everything that you might expect from mission-critical database, something that you can rely on and get your data super available. But all the logic behind the scene, how do you run this query? How do you analyze the query? How do you optimize the way you are running the query is being done by the FalkorDB, practically a module, you're right, it's still a module. But from the end user experience, they're just working with the database. They're just working with a graph database like any other graph database. They don't really care that we are using Redis as kind of an infrastructure container behind the scene. We are not kind of exposing any of other Redis API. We are just using it as a container that we can easily maintain. And user, by the way, really familiar with how to maintain a Redis, how to maintain a Redis cluster, how to run it in production. So for most of the DevOps, it's like managing a Redis cluster, but instead of getting a Redis API, they're getting a graph database API.
And that direction is still OpenCypher or something very, very close to OpenCypher, because that was something, I think, if I recall correctly, that originally RedisGraph used, which of course was invented, for want of a better expression, by Neo4j all those years ago, which was then still called Cypher, if I'm not completely mistaken.
We have adopted OpenCypher from the very beginning of this project. We felt like this would be the right query language to go with. One, because it's quite popular due to Neo4j and other vendors who have adopted it. But secondly, maybe it really made sense back then when we evaluated the different options that we had. And basically, it came down to just two query languages. One was Gremlin, and the other one was Cypher, and I felt Cypher to be a little bit more compelling. And I think that over time, Cypher had won the market. For the past, I think, 1 or 2 years, a new query language for graph, a standardized one, had been released, GQL. So I think that over time, and it's going to take a few years for the industry to move from any query language that is being used to the standard one, GQL. Luckily for us, it closely resembles Cypher. But we are, I would say, Cypher compatible. Cypher is a rich language, so it's hard to get every single feature of the language implemented, but I would say we are about 85% there. But I think that now we're going to try and then see how we're going to shift from the current query language to the standardized one, GQL.
Interesting perspective, Roy. And changing tack just a little bit. I mean, there are numerous graph databases out there, and with this latest craze called machine learning, never mind artificial intelligence in general, everybody's trying to find their sweet spot. When I look at your website, you position yourself aggressively in the RAG space in terms of retrieval augmented generation with regards to providing infrastructure for knowledge bases, for knowledge-based systems rather, whereas, and funny enough, Redis is positioning themselves more and more as a vector database, targeting, I'm almost tempted to say, something in the very close neighborhood with regards to an inference infrastructure for machine learning, i.e. where all those years ago, Redis AI, I think, which is now defunct, if I'm not completely mistaken, originally came from. But needless to say, given the vector database approach, this is something from a technical perspective, something slightly different. So if Redis is going down the vector route, and if you're targeting the RAG market, you're both heading for the sweet spot, machine learning. Apparently, this is where all the moolah is, right? Going forward.
Yeah, I think that everybody sees the great potential behind AI. And one of the main issues that you have is taking an LLM and trying to have it working with proprietary data or closed source data or private data, what have you. Because the models, OpenAI, Gemini, Llama Index, and such, all of those were trained on publicly available data. But if you are a private company with private data sets and you want either your customers or your employees to be able to utilize AI and LLMs, for example, to have a conversation with your data or some type of application such as a chatbot or some type of an assistant who has access to your proprietary data, you can't just use an LLM as is. And so the solution that came to be is that it came to known as RAG. And the idea here is to present the LLM with the user question given in a natural language, in addition to some context. And the context is the private data. And the big question is, how do you extract the relevant context for the given user question? And there are numerous ways to go about this. The current approach, the predominant one, is to utilize a vector database. And the idea is basically to perform a semantic search given the user question, try to find bits and pieces of data that are semantically close to the user question. That becomes the context. And then the LLM is responsible to produce an answer. The main problem here with the predominant approach here with vectors is that we're relying heavily on the semantic similarity. And I can give you a few examples of where this approach breaks down. So consider a situation where you are asking a question that needs an holistical view over your entire data set. These type of questions are usually either aggregations, like how many articles are there in my catalog? So you need to perform a count. Or what is the maximum value for some attribute? Now you need to perform a maximum. This would simply break in the vector approach because when performing semantic search, you usually are limiting yourself to some number, let's call this number K, of results. And K is usually not the entire data set. And so the LLM would be extremely limited when computer deaggregation. Same things happen when you need to perform some type of sorting. So give me the latest 3 articles published. This is a sorting issue, and you would not be able to do that. Another thing to think about with vectors is the fact that the database itself doesn't really understand the data. It's just performs searches in some n-dimensional space. So for example, if your data is composed of statistical values, let's think about maybe heart rate and level of oxygen in your blood and any other type of such statistics. When you're asking a question such as whose patients might be in distress, now with vectors you are performing a similarity search, and you would not be able to utilize those statistics in order to locate or find the patients in distress. There are other examples where this approach fails, and the alternative which we found to be really compelling, is to either do a hybrid type of RAG system that combines both semantic search and graph-level subs. Basically, the idea is to take your proprietary data and create a knowledge graph out of it, capturing both the entities and the relationships within your data. And now the gist goes by giving a user question, present this question to your LLM model in addition to your knowledge graph topology. So the LLM understands how does your graph or data looks like. And now the LLM can compose a query to retrieve the relevant context for it to answer the question. And this is what we're trying to provide to our customers, basically taking what we've built over the years, our graph database, which is extremely fast and able to keep up with user interaction, and provide it as is, in addition to tools and frameworks to create GraphRag applications on top of it.
That's certainly very interesting. Not something I thought about, but yeah, as you said, semantic search is obviously limited to the relationship of and then the distance between words and things like that. So just you mentioned adding knowledge graph, right? So if we're thinking about domain specific knowledge in an organization, their own private knowledge base, how would you go about, let's say, turning that into a knowledge graph? Is that something that the user has to do themselves? Do you have tools to help with that? Is it something that you can automate by saying these documents are related or these parts of documents are related, or use other properties of the proprietary documentation in terms of, let's say, I don't know, keywords or things like that? How do you go about building a knowledge graph on a complete set of domain-specific data?
Right. That's one of the big questions for people who are thinking about trying out GraphRag. We usually look at it in two ways. It depends on the user data. So, for example, if the user comes with structural data, for example, maybe a document store or a relational database, then usually the transition is easy to perform. Basically, it's converting structured data into a graph. And this is just a straightforward transition. Things get a little bit more challenging where the user data is unstructured, like Word documents, PDFs, websites. And in here, the approach usually is to try and predefine the ontology which would better or would accurately describe the data domain. So, for example, if we're thinking about maybe some tourist agency, the ontology might contain touristics sites. Maybe it would include hotels, locations, restaurants. These entities and the relationship between them would become the ontology. This would also be enriched with different attributes. So, for example, maybe the restaurant's name and maybe the restaurant rating and so on and so forth. Once the ontology is clearly defined, then we can use an LLM and instruct it to find both the entities and relationship complying to the ontology within the unstructured data.
And not everybody is familiar with, on a low level, with deep learning and the new web and stuff. The ontology, of course, being the semantic framework around this. Did I get that right, Roy?
Ontology, usually the way that I think about it, is very similar to what others would think about the schema of a relational database. It's just a way of defining your data. So if we're thinking about a graph, what type of entities can be found in the graph, and which type of relationship or edges are connecting those entities to one another, in addition to which attributes are associated with either nodes or edges. So it's just a definition of how the data looks like. You can think about it maybe as a schema for your graph data.
But I didn't want to interrupt you, sorry, just for the benefit of the audience out there.
Right. So with the ontology defined, we instruct an LLM to extract entities and relationships that comply with the ontology from the unstructured data. Once those are identified, then we can go ahead and populate the graph with those findings. I should say that we, as part of our development, we're developing our GraphLog SDK, which includes the utilities for creating knowledge graph from both structured and unstructured data.
So, if I understand that correctly, this is another niche. I mean, vector databases, in my books, facilitate the inference phase of an ML, like an LLM model. Whereas you are saying you're heading specifically towards the RIG space with regards to ontologies, but also provided to some extent a much more enriched infrastructure for that sort of niche.
I believe so. I think that one of the key reasons why vector database had such a huge adoption is the fact that there's no way to go wrong about it in terms of how am I getting my data into the database? How do I perform the inference? It's a straightforward, there's no way to get lost. You take your data, you run it through an embedding model, you're getting a vector and you put it in the vector database. Straightforward, it's not messy. With a graph database, you need to put in the work. But the reward is worth it, at least in my eyes, for several reasons, those that I've mentioned before. But the fact that you have converted either your structured or unstructured data into a graph, first you can use it in a LLM type of a system or a RAG type of a system, but usually after people are seeing their data represented as a graph, other use cases tend to show up. It's like a new avenue had been opened, and now new ideas start to flow in, and you can utilize your data in new ways that were simply not possible before. So they start out by trying to build a knowledge graph for the RAG system, and after that, other applications usually follow up. And with vector database, I think you're pretty much limited. You are working with a vector space which you can't really explain, you can't really navigate, and you're simply relying on semantic search, which is limited. And so what we've seen in the industry is that companies that were focused solely on creating vector databases or vector indices, I think that they're going to struggle real soon, because all of the other vendors, be document databases, relational databases, graph databases, everybody's looking at it as a indexing capability. It's not a standalone database. It's just a search capability. And everybody just adding this new variation of an index to their system. And so from a user perspective, I don't think it makes too much sense if I have my data in Postgres or in Mongo or in Redis or whichever database that you're using, and I need semantic capabilities to search through, I'm not going to add a new vector database into my stack. I'm just expecting my current database to support this new type of indexing. And that's what's happening. We see it all over the place. And I think that would lead to a hybrid type of a RAG system where you're combining both the semantic search, but then you follow up with graph traversals where you're trying some custom strategy to go about your retrieval, which combines graph capabilities with semantic searching.
Yeah, no, that sounds like it's quite powerful, the graph RAG. How are you finding this so far? Is it the case that, let's say, your existing graph users are moving into graph RAG as well, or is it you finding a whole new set of users that are trying out graph RAG and then also discover the existing graph capabilities, obviously, of FalkorDB?
I think there's a 50-50 split here in terms of what we're seeing. So the first half are users who had tried RAG system which are vector-based, and they are simply unable to reach a high accuracy in terms of getting the right answers from their system. And so as much as they are trying with prompt engineering, doing their best to guide the LLM to provide the right answers, they're simply don't feel comfortable putting what they have in production and giving it to their users. And so those customers are in a bundle, and they're trying to find a different approach which would get them to the accuracy that they need. And so they, usually they do some reading and they find about graph RAG, and then they come knocking. So this is the first half. The others are simply newcomers from different verticals. One of those that we are currently working with is regarding code analysis or systems such as GitHub Copilot, where you're trying to get a better understanding, or some assistant that would help you reason about and navigate through your code. And it makes a lot of sense to represent this as a graph. And so people who are just avoiding vector databases for their RAG system to begin with, and they understand that the right approach for them would be to model their data as a graph and then just put an LLM on top of it.
Changing tack just a little bit. I noticed when checking out your GitHub repo that the code is under this SSPL. Similar to Redis, this is not a license that is acknowledged by the Open Source Institute, as in the OSI. I get the angle of cloud and all the rest of it, but maybe you care to elaborate just a little bit in more detail why you specifically chose this SSPL in favor, or rather compared to the original 3-clause BSD that Redis was under all of those years before Redis, the company now, decided to change this license a couple of moons ago.
Yeah, I think you can see it's there's been a trend in the industry in the last 3 or 4 years to switch away from the permissive license like BSD or MIT, at least on the infrastructure level. Different tools, obviously the one that started the SSPL license are MongoDB, but then other joined, including Elastic and Redis and Neo4j, many more, all with parallel license, like similar license that have some similar limitations. The motivation behind it wasn't to limit the users. We are still encouraging our users to use it for free. They can fork it, they can change it, they can contribute if they want. They can do whatever they want. They even can redistribute and use it in production, no limitation whatsoever. The only reason that license was kind of pushed by the industry and was adopted by so many open source but used to be officially open source, but these days like source available because, as you mentioned, it was not officially recognized as an open source license. It's because the feeling in the industry, there are many companies or many communities that are contributing a lot of time, efforts, and resources in developing open source projects, like the big ones that I mentioned before. But at the end of the day, who is making most of the money out of it, who is really benefiting from it, are the cloud vendors. The cloud vendors that are not contributing too much, if any, to the infrastructure itself, to the database itself, to the database development itself, but are having an unfair advantage when they are selling this product as a service. Again, I don't think anyone kind of wanted to completely block others from selling these products as a service, but because of the unfair advantage that these cloud vendors, which are practically a monopoly, right? They're completely controlling the way people are deploying their new applications, so they can give unfair advantage to their own managed database solution. So it means that whoever is developing the database cannot really monetize as good as the cloud vendors from what they develop. So I'm saying, so instead of getting into the situation when you are starting as a fully permissive license and then find out one day that someone else is kind of eating your cake without really contributing back, where you are putting all the efforts, the money, and the time, and someone else is making all the money, we decide to kind of, from day one, have this license. And I think we can see it from other open source projects. I call it open source, by the way. I think it's open source because from the end user perspective, maybe the only one who might not consider it open source project who are the cloud vendors. From the end user perspective, it doesn't really add any limitation that more common open source license would have enforced. And I think that we see it. We see users using us in production. We see users still using Elasticsearch, and Elasticsearch switched back, but Mongo, and they still use Redis, and they still use other products in production, and still forking it. We have forks, we have users contributing. And I think there is understanding that if you want to maintain a healthy open source community, if you want to maintain a healthy maintainer, you need to let the maintainer be able to monetize it without impacting the users that want to really use it as an open source or play with it or manage it on their own. But you need to give the original maintainer the opportunity to monetize it in a fair environment. Meaning, I don't care that others will join it and even use it in production, but I want to make sure that I have fair environment where I can compete on monetizing this open source product.
It's interesting that you just mentioned Elasticsearch, because as soon as Elasticsearch originally changed the license, AWS as an Amazon forked it and named it OpenSearch. Mm-hmm. Same actually happened with Redis. As soon as they changed the license, I think that was prior to 7.2, a group, let's put it this way, forked that version and named it Valky. And within minutes, I'm tempted to say, no, rather it was weeks actually, it was under the auspices of something called the Linux Foundation. Now, given the importance of the LF, never mind the sponsorship, because all of the major hyperscalers are sponsoring this, it's probably not fair to say that they're not contributing back. Or do you disagree?
You mean now when they're managing their own project and when they have to contribute, because now if they won't contribute, yes. No, because now if they won't contribute, they just won't have a product, and they are not willing to kind of give up on this money generator product. But we were trying to have this fair game before. We were trying to understand if we can get this fair game when they cooperate with the open source communities, when they maybe partner with the open source products. And most of the big open source products felt like they there isn't really a commitment into this partnership. There was it looked like partnership, but it really didn't really feel like a partnership. And now I think you can see that obviously now if they want to continue having the same, free version, they need to maintain it on their own. So that's what they've done with open source, with OpenSearch. That's what they've done with Valky. And the question is, how it will it retain the same agility that the original product had? Like, will Valky move as fast as Redis? Will it move in different directions? Will it split the community in a sense, right? It's already splitted, but will it really go into two different products? You can see this. You can see that in OpenSearch, it did split the community, like completely split the community. These are two different products. The compatibility between them is not that high anymore, and you can see that what I think made the Elasticsearch team feel comfortable in reopening the product from SSPL to a more permissive license.
A very philosophical positions indeed. Before we close this up, as in wrap this up, any final call to action? Are you still looking for people to contribute? I noticed that you are also hiring your first solution architect. So that means you're ramping up sales. So if there's anything you want to put in front of the community, now's the time.
Yeah, so we are growing very fast. We see the demand. It seems like there is a very nice realization in the market that, as Roy mentioned, vector database can get you so far. If you really want to have more than trivial application, more than just search-based applications, then you need to have you need to have something that can really hold knowledge and retrieve complex knowledge, like a knowledge graph. And we see the community moving so fast, and we see everyone are talking about it. It seems like everyone that having some kind of a platform that is trying to help you build your own LLM-based application is introducing a way to model your data as a graph and retrieving data from a graph. So we see the community moving very fast. So we already have our own database and a service on the different clouds. So we see users coming in, registering, and starting to use. You can even get your free version there. We're allowing fully free version. You can even run it in production. And we see very nice adoption. We just launched, by the way, this week, a startup program that is giving you a paid version with more reliability, obviously, and better SLA, but super cheap, so you can start, build your application and grow with us, and still get the super fast graph database. You are not limited. We are not limiting the startup version by throughput or something like that. We are just giving you a smaller database and you can grow with us. And in parallel, we are working on these different open source. These are fully open source. The only thing that is practically SSPL is the database itself. But we are building a nice ecosystem of product that we love to see people coming in, playing, give us feedback, and maybe contribute. As Roy mentioned, we built a very nice, what was supposed to be a demo, but slowly becoming a solution of source code analysis. We know how to analyze your source code, deploy it as a graph, and then let you talk to your code. We call it Code Graph. We also develop our own FalkorDB browsers that allow users to come in, look, see the data, really see the data, see the ontology. This is something that is unique to our graph database, that will let you see the ontology, edit the ontology, and see how it impacts the way you are working with the data. And lastly, we are all the time contributing to the different open source LLM-based platforms like LangChain, Llama Index, GripTape, Mem0, and many, many more. We believe that the whole experience of using a knowledge graph should be as simple as people expect it to be, as they are using today any other RAG solution, as they are using the vector database. We are trying to make it as seamless as possible and as smooth as possible. And for that, we believe the most important part is to bring it to them, to the community that they are used to work in. Like to work, if they're used to LangChain, that they can consume FalkorDB in LangChain. If they're used to work with Llama Index, we are there. And we'll keep on contributing. So by the way, if you have any open source, interest in open source that you want us to extend and contribute, we would love to. If you have any ideas, come forward. We are still believing in open source. We're still believing in having it all open. We didn't close anything. Everything is open completely. And we are not having this kind of enterprise version and open core and closed crust. Everything is fully open and available for our users.
Great, Guy. And of course, the links for the starter pack will be in the show notes as soon as you tell us that the check is actually in the mail. Jokes aside. Roy, you had to run. Let's wrap this up. Why don't you do the boxes first? As in, what's your pick of the week?
Oh, yeah, sure. I think that what we realize is that obviously everyone are talking about DeepSeek, right? Everyone are doing DeepSeek in the last 2 weeks, and DeepSeek really kind of stir the water around, and everyone are saying, how did they do that, right? So the first thing that we've done was to kind of compare between the different models. And I have to say, we thought models are already super smart and the advance will be slower, but every model is smarter than the one before. So what we've done, we started to see how good are they with generating knowledge graph, how good are they with retrieving knowledge. And I would have to say that DeepSeek is super smart, but I would recommend testing Gemini. Gemini 2.0 really surprised us on how smart it is, how good it is in understanding your unstructured data, and it's really surprising how fast it is with the Gemini 2.0 Flash. But I guess by the time this podcast will be released, there will be 5 more new.
You never know.
Like 10.
So, yeah, what's your POX, Martin?
I have 2 this week.
Go ahead.
One being a small French brandy manufacturer called Courvoisier, which has great medicinal value. Anyway,
does it now? Excellent. If you're listening, the email address is sponsored.
Yes. If you're ever infected by the flu, then that's the only medicine you need.
And your second POX, Martin?
Second POX is something called The Completely Made Up Adventures of Dick Turpin, which is yes, you've heard of it. Anyway, it features the
Martin. We met the guy,
the goth from IT Crowd.
Yes, Martin, but Dick Turpin rings a bell, right? Dick Turpin Roadshow. We met the guy at FOSDEM.
A different Dick Turpin. Well, obviously there was only one Dick Turpin, but yes, nothing to do with the Dick Turpin Roadshow. No.
Okay, fair enough.
Yeah.
Because of course with the show notes.
Yeah.
Okay, cool. My POX is actually a guy called George Lucas, famous inventor of Star Wars. I came across him a couple of days ago when I kind of took a trip down memory lane, and actually he started out almost in the kind of, I almost have to say 60s, 70s, with a couple of, I wouldn't say stillborns, but there were a couple of interesting movies before he actually made big time with Star Wars and all the rest of it. For example, Labyrinth and THX 1138, if that still rings a bell, which he kind of did as one of his first
probably not
movies.
To our audience, yeah.
Exactly. I mean, if you're not kind of 60 plus like Martin and myself, you probably won't know these movies. These, of course, with the show notes. But of course, Lucas is known for Star Wars and some other interesting movies that made the big bucks. Like, for example, actually, Martin, you should know this too. Indiana Jones. The series,
Okay,
as in
yes, I've heard of it.
yes. Franchise. Yes, he did that actually too, all those years ago.
Aha.
And with that,
Indeed. Thanks very much, Guy and Roy.
Roy, yes. I think Roy is no longer with us, but in terms of you had to drop. Guy, thank you very much, and good luck with the company.
Thank you very much. Thank you for having me. It was a pleasure.
This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness. Thank you for listening.
We hope you like this feature presentation. If so, please spread the word. If not, please let us know. Feedback at linuxinlaws.eu.